Hello, and welcome to Vitruvius. Our Vitruvius engineer, Brian DeMeza, will be giving you an in-depth walkthrough with some helpful information to get you started.
Alright, so let's open up a column design module. Alright, so the column has opened and we can see that it opens horizontally. But we can see on the right of the diagram that it is a column and not a beam, as well as the reactions are rotated to show you that it is a column. The bottom of the column is the left side and the top of the column is the right side. As with all of our design modules, the Properties tab is on the left, loading diagram in the center, some diagrams on the right, and spans, loads, and adequacies in the bottom. So let's start in the Properties. Here at the top we have our LRFD or ASD calculations. We have our wet or dry factor for wood, so we can click either of those to toggle between the two. And as we move down, we have the column properties. So a little bit different than some of the other design modules, we have our design module specific properties right at the top before material. So for this one, the column, we can set a load eccentricity in the x-axis or in the y-axis. We can leave the in conditions as is, or we can uncheck it and input our own. We can also select the gear icon here, which will bring up our in condition pop-up, and then we can select the in condition based on our reactions, just like you would if you were designing by hand. It's easiest just to leave that as an auto-calculate because it does it based on the reactions. We can also uncheck to input our own stability factor, or we can use the checkbox to create a cantilever column. Now if we go down to material, we have our template, material type, species, and grade. Similar to the beam design modules, as we select through different materials, we're presented with different options based on the material type. So for solid sawn, we can use the drop down to select the species and then the grade. We can also use the checkbox to include the self-weight in the calculations. Let's move down to size, where we can select the number of laminations, the width, and the depth of the column. For options, we can choose to have a round column, making it a post, which clicking this will change our size to just show the diameter. And then below that, we have the factors. So we have a temperature factor, an incising factor, and a creep factor. In the loading diagram at the top, we have our top toolbar with our calculate, auto size, save, and after calculations, we'll get our print preview. We also have the location name, so we can change this to column 1 or whatever we'd like to call it. And we can also close the tab on the right. The next toolbar down is our view load type. And so right now we are in all, but we could change this to live or wind or seismic or whichever one we want. On the left, we have our add load toolbar. So we have all the loads here. On the right, we have our calculators and an add or delete span. So right now we have no loads on the column. So we could add a distributed load, a trapezoidal load, a point load, an axial load, a moment, or a linked load. So if we wanted to add an axial load, we could add a point load or a distributed load. So we could add a distributed load along the z-axis of the column. So now once we add that, we see the load. We can click it to edit it, or we can go down here to the load card, edit it, or delete the load. We can change the reactions by clicking them. So we can set this to a fixed. We can also add multiple spans. So if we want to add another 10-foot span, we can do that. We can add another one. Let's say it's 5. So when we delete spans, we delete from right to left. So we can't click the middle one and delete it because we will not have continuity anymore. So we need to delete that one and then that one to go back to our original column. So now we have a distributed load in the y-axis acting on the column. So if we hit calculate here, Our adequacy cards automatically pop up in the bottom, and we can see that we are failing in bending compression and in bending stress, but passing in the others. We can see on the right, we have our shear and moment diagrams, as well as the axis, so we can look at the axial forces. Let's go back to the y-axis, and then we can also select the load case in this drop-down. Now we can adjust our property to make sure that the beam is passing, or we could roll with this. Even though it fails, we can hit print preview and see we have failed nice and big at the top. And we have our beam properties, strength properties, some of the data of the beam. We show which modes failed, and the reactions calculated, and the loads, and any notes that we have applied. Check our other walkthroughs for more information on the other design modules.
We hope this information was useful to you. The Vitruvius team is standing by to assist you directly via email, phone, or even a remote session. Thank you. We appreciate you being a part of the Vitruvius project.